It's a great pleasure to hand over to Dame Ottoline Leyser, who is Chief Executive of UK Research and Innovation. So ultimately has supported the creation of DAFNI and its continuation in the coming years. And this is a fascinating time for UKRI, in particular in the context of digital research infrastructure and the possibilities that this holds for the research and innovation community within the UK. So it's wonderful that you've been able to join us this morning. Ottoline, I know you're extremely busy, but thank you so much for joining us at this launch, and we're very much looking forward to hearing from you.
Thank you very much, Jim. It's really a pleasure to be here to celebrate the extraordinary amount of work that's gone into getting DAFNI to this point, and to getting it to the point where it really will continue to be able to deliver really important understanding to inform the national infrastructure strategy. I think DAFNI is kind of emblematic of a much bigger trend in research and innovation, and I think as a CEO of UKRI, it's really exciting to see that trend and to be in a position where we have established UKRI and brought together the 7 disciplinary research councils with Innovate UK and Research England. And in that form, I think we're much better able to respond to the revolution that's currently going on in research and innovation, which I think DAFNI is emblematic of bad grammar, sorry. I want to share some slides that I think will talk about this. So hopefully everybody can see that.
Yes, I can see.
Wonderful.
Perfect, that looks good.
So as I mentioned, UKRI is a relatively recent organisation. We're a little over 3 years old now. We are the largest public funder of research and innovation in the UK, and we bring together the 7 disciplinary research councils, Research England, who work closely with the equivalent bodies in the devolved nations, and Innovate UK. And that means we cover all the disciplines and all the sectors where research is conducted. And I think that ability to connect up is crucial to our ability to operate effectively, to connect the extraordinary discovery research base we have in the UK with impacts of various kinds, with public good ultimately. And that's, as I will talk about a lot, not a linear relationship, and thinking about those systems level relationships is really core to everything we do, particularly in policy. And that's why I think DAFNI is such an important development for everybody. So we are a public body. We spend a very large amount of taxpayers' money every year, and so we are obviously accountable to government. And crucially, as I say, we're part of a system, and we're a kind of important node in a system. And we work with academia, businesses, public sector, third sector, and of course, crucially, international partners to try to make the most of the extraordinary creativity and innovation that we see in the research and innovation system to deliver for the public, for everybody. So I think what I want to say a little bit about is the power of these transformative technologies, these platform technologies, which can be used in an extraordinary range of domains, which seems particularly relevant in the context of DAFNI. And over the course of the history of research and innovation, it's really clear that technological developments are crucial. They can underpin both discovery and innovation. They open up entirely new fields of research because they make possible things that were not previously possible. And of course, as a result, they also open up new opportunities for businesses and also for delivering really high quality public services, so for policy. They can also make research, businesses and public services much more efficient. I've lived through a number of so-called technological revolutions in my research career, and they were technological revolutions, and they were really exciting, and they have completely changed the types of question that it is possible to ask and expect to get an answer. I've always been slightly skeptical of the notion that all of these revolutions change the way we do science, because for me, fundamentally, science is about tackling challenges, about asking questions and trying to find answers. It's about understanding how things work, and it always has been and it always will be. And you bring into it anything you can to help that better, help do that better and more quickly and more effectively. And that these transformative technologies kind of roll into that for me and really drive the rate of change and allow you to access questions and answers that would have been really difficult before. And as I said, I've certainly seen that over the years I've been in research, and it's been very exciting. You shift the bottleneck somewhere else. And I think that's another crucial point that I want to make as we go through the presentation. So in that time when I've been doing research and looking back, it seems to me that many of the transformative technologies that we've benefited from so far are about doing particular jobs more efficiently, or seeing things that has not been possible to see before, measuring things that you haven't been able to measure before. And you know, if you look at Nobel Prizes, for example, I'm a biologist, so I go fairly rapidly to biological examples, and there have been huge changes in microscopy over just the time I've been doing research. The things we can now see down a microscope are wildly different from the things we could see before, both in terms of the resolution that is available, so the size of the thing that you can see, and also in terms of being able to see things that are still living in biological systems and dynamically going about their business as biological specimens. On the flip side, there've also been massive advances through looking at things that are a very long way away. So telescopes have been crucial, various kind of funky kinds of telescopes, in, again, delivering a number of Nobel Prizes. And in that context, they're quite often about being able to gather the data that you need to test theory. So it's not just about a new way of looking at things, which you can win a Nobel Prize for in microscopy, but even so, it's the technology that's really underpinned the prize. There have been a lot of prizes, again, in the biological context, for new ways to manipulate systems. So lots of genetic modifications of one kind or another, most recently, very obviously CRISPR-Cas9, but a whole range of prizes for technologies that have really helped us to get into understanding how genetics works, how the genetic code drives organismal development, for example. And then, of course, there have also been huge advances in robotics and automation, for which it's very difficult to win a Nobel Prize, unfortunately. But nonetheless, machines that will do things for you, which is fantastic. So looking back, technologies really have changed our ability to do things in a really impressive way. But I think we're now at a new point in proceedings precisely because of these extraordinary technologies. So I think as a result of these past technological revolutions, a lot of those bottlenecks I was talking about, the rate limiting steps, have moved away from the things and the tasks towards the relationship between the things that you can now see so much easily, and how they function together to deliver a dynamic, changing, rapidly changing system. And I found this incredibly exciting, again, in my research career, going away from huge amounts of work when I was a PhD student to identify, one gene that did something interesting, to, as I stepped out of the institute I was running, which was entirely focused on understanding the dynamic relationships between multi-scales of organization in the cell, genes, molecules, cells, tissues, whole organisms, that allowed the genetic code iteratively interacting with that organismal level information, and indeed environmental external information, that iterative cycle of information flow and information readout that drove the development of, in my case, plants. So really about how systems work, not about the bits that the systems are made up of. And I think that this is now the frontier, and this is exactly what DAFNI is all about. And so this requires us to understand systems and processes and all kinds of nonlinearity. And when I say nonlinear, I don't mean just the mathematical nonlinearity in the relationship between two things, but also the way most of these systems work. They are absolutely stuffed full of feedbacks. And that means they don't really have a beginning and a middle and an end. They are systems, and the wiring diagrams of those systems and the dynamics in the arrows of the wiring diagram are absolutely crucial to understanding what they do. And we have, as people, really poor intuition for this kind of stuff. And that's why it's so important to develop tools that not only allow us to do the analysis, but also that help us to develop the intuition we need to understand these kinds of dynamical systems. So as I said, we are very deeply kind of wired as humans to think in terms of these linear stories with a beginning, a middle, and an end, a cause and an effect. It's very deep in how we think, and it's become, in my experience, ironically, through this period of understanding the importance of complex systems. At the same time, the way that we decide to develop policy, for example, or rules in our organizations or whatever it is, processes, has dug itself deeper almost into this beginning, middle, end, cause and effect narrative. So, for example, we're very obsessed these days with smart objectives. We see something, we'd like to change it. We'd like, you know, better representation from different communities in the research and innovation system. It's very important. And we figure out some interventions that we're going to make, and we want them to be specific, measurable, attributable, realistic, fair enough, time limited. But if you're trying to influence a dynamic feedback regulated system, many of these ideas are just not a helpful way to think about the intervention that you're trying to make. And I think that's really where the kind of DAFNI tools come into their own, because reality and certainly all of these interesting problems that we're now tackling are really not linear. And more than just they include nonlinear mathematical relationships between parts, they don't have a beginning, a middle, and an end. They are heavily feedback regulated, and the whole notion of cause and effect becomes quite problematic in that situation. If you don't have a start, you know, if A influences B and B influences A, that the notion of cause and effect is problematic. And in my experience, thinking in terms of these smart objectives where you want to have a clear, traceable relationship between the intervention and the output, it becomes quite inhibitory to the interventions that you pick. And so I think tools that help us to understand these complex systems and therefore give us the kind of courage really to intervene in them in ways that are where the outcomes are dynamically capturable, and therefore we can tune our inputs intelligently. I think they're absolutely crucial to allowing progress in these really difficult arenas, like how you build the best infrastructure for the UK. We need to think much more about these difficult phenomena, like things like tipping points, where you can be intervening and intervening and intervening and absolutely nothing happens, and then suddenly things change. I've emphasized feedbacks quite a lot, which really make it very difficult to intuit. And then there are these, the flow of information across different scales in the system, which I've also emphasized, leads to these extraordinary kind of emergence properties. This is Conway's game of life, where very, very simple rules about how individual squares should change from black to white can create across a tile these kind of behaviors that to the human eye anyway look like you know, designed complex things when they emerge from incredibly simple rules at a lower level of organization. And this is a cartoon of these traffic waves that where you're driving along the motorway and suddenly you're in a huge queue, and it's not because anything blocked you, it's because of kind of amplification of over braking that started when somebody was distracted and wound up having to brake more rapidly than they were intending to, and they overbrake, and then you propagate these waves of kind of car pile-ups back down the, not crashes, back down the motorway. And so understanding this kind of non-intuitive system becomes absolutely crucial in addressing the many of the key challenges we face. And I think the sort of transformative technologies of now, the next generation of transformative technologies, are very much focused on that problem. They're not what are the bits, they are how do these bits work together to deliver these non-intuitive type behaviors. And I've been very interested for a long time, actually, in the context of the biological systems I've worked on for many years, in how we can help to build that intuition and common understanding of at that level of interaction of parts rather than the parts themselves. Can we develop kind of parts list for those interactions, for example, which will help us think about how systems work together, how those relationships build. And so when you put together a set of those relationships, you get out a particular systems behavior. And that's the kind of thing that I'm kind of excited about. Right across disciplines, you can see it happening in different contexts. And as I have said, DAFNI, I think, is really a good example. And within UKRI, we have been developing a set of priority transformative technologies. It's certainly not an exhaustive list, but the ones we've worked on hardest so far, where it is really clear they're going to be really important in delivering exactly this agenda. They're the next generation, and they are all about dynamical systems almost, rather than the previous generation, which were about understanding better the parts, and either by being able to measure and see the parts themselves, or by being able to work more quickly to measure and see the parts. So AI is a really obvious example. Digital twins, which is all about dynamical modeling, as in DAFNI. In biology, we've gone from techniques to allow us to change the genetics in cells, for example, those GM techniques I highlighted in the Nobel Prizes, through to a new and emerging field that has been kind of called synthetic biology and has become engineering biology, sort of merging in systems biology. That it's quite a kind of complex set of terminologies, but we're settling now on the term engineering biology, because it's about intervening using those fabulous techniques previously in a way that we understand sufficiently the wiring diagrams to know what will emerge. So you can engineer a cell to perform in a particular way, to produce a particular chemical from a particular feedstock, for example, really opening the way for a whole new kind of bioeconomy, which is very exciting. Quantum computing is obviously much talked about at the moment, but for me, the most exciting thing about it is the potential to be able to do optimization problems, to solve optimizations much more rapidly and effectively. And those optimizations of systems behavior are exactly the kind of thing that it has become a real bottleneck. And then we've moved on from robotics, kind of have a robot that does this boring task, much more to autonomous systems, which is, I've got a robot doing this boring task, whatever it is, but it is wired into and responsive to a huge range of external inputs, and of course its own actions and the consequences of those actions, and therefore works dynamically to perform tasks that previously would have required multiple separate human interventions. So the next generation of transformative technologies are these kind of multi-scale, dynamical integrators, more than the tools that we need to measure the parts at individual scales. As I've said, DAFNI is a fantastic example of exactly that going on, modeling, simulation and visualization to support the National Infrastructure Plan. And critically also, I think the system of systems approach, as I say, I think none of these, despite the need to think about systems, the only sensible way to do that at some level is to break them down. And then we need ways to build them back up again, which is essentially what a system of systems approach can do. So as I said, really key to all of this, I think, is to support both researchers and the wider stakeholders, so publics and policymakers, to develop intuition around these very difficult concepts, so that the sort of straightforward, intuitive solutions to which people reach become the right solutions rather than the wrong solutions, which tends to happen now because we unwrap everything into this linear cause and effect, beginning, middle, end stories. So that intuition development, I think, is absolutely central to what goes on. And beyond that, the ability to connect these various communities around these tools is always an incredibly powerful way to move forward on these complex interdisciplinary agendas and therefore accelerate impact. So I think particularly crucial at this moment in the development of this, these new transformative technologies that are at a different scale, that are therefore rather non-intuitive and doing mysterious things. This is where we really need to think very hard about the relationship between the technologies, certainly the research and innovation community, but everybody else as well, policymakers and publics. And these tools really can be part of an ongoing priority for me, which is to break down the barriers between the set of activities that is currently defined as the research and innovation system and wider society, because these tools are going to be everywhere in the way you move around the country, for example, on the transport system, and having that deep embedding all of this stuff, these ways of thinking right across society, I think is crucial to making this whole thing work and to bringing everybody along, to creating a kind of common endeavor that everybody can get behind and feel part of and feel that they have some kind of agency in their lives. So I think public value then is absolutely central. So for digital twins, for example, the focus on transport and housing and health is really positive. These are meaningful things for everybody. And we need to think really deeply about how all of this work is better integrated with decision-making in a way that, as I say, brings people along. So we're working with people and not doing things to people. And we need to create this much more symbiotic and dynamic relationship between a really inclusive research and innovation system and these technologies so that they can be rolled out rapidly. I just want to flag at the end a really interesting project that I'm quite a fan of that is in Taiwan, which is called Taiwan. I encourage people to go and look at it. It's a kind of technology platform integrated with a range of other activities that are kind of crowdsourcing for democracy. And there are particularly a range of very interesting dynamical tools for consensus building on key policy questions for the very wide range of participants in the program. And deep in there are really useful visualization tools that help people to engage with these complex decisions and the issues that underpin them. And so not only can we use these kinds of tools to understand the systems, but we can also use them precisely to bring people into that understanding and to build a much greater kind of participation in the decisions that we need to make. So I'd say then the challenges for this new generation of transformative technologies are adoption and diffusion right across the systems where they're valuable. And as I say, the kinds of things we're talking about here that bring together different communities around the technologies are, I think, really valuable in helping to drive this kind of adoption, diffusion, and help technologies jump from one domain to another, which I think is really important. Linked to that is accessibility, which means accessibility for the people who have very specific primary uses, but also from a much wider range of stakeholders who are able to engage with what's going on and how they're being used, and that maps onto inclusivity, both in a sort of small and a large sense, and communication. And I think really through thinking about those first four challenges, the importance of building a really sustainable systems for getting the most out of these technologies. And that means embedding them across the system in that way, but also finding ways to engineer the funding system in such a way that it supports sustainability. It's not just, oh, this is a flashy new exciting thing, we'll invest lots of money in it now and then we'll forget about it because it's no longer flashy new and exciting, despite the fact it now underpins everything. but a system that drives the rapid developments that we're all excited about, but also then creates sustainable support as the technologies do embed across the wider system. So I will stop there, and thank you very much for listening and for the opportunity to join this really important celebration. And I'm really excited about hearing over the years the wonderful things coming out of DAFNI. Thank you.
Thank you so much, Ottoline. That really resonated with themes that both motivate DAFNI and we've been grappling with during its creation and in all of the research which goes on around it. Both the complex systems, motivation and infrastructure clearly is one. It contains technologies interacting with people and the natural environment, and not only new technologies, the digitization and materials, but also a whole load of old stuff, which is central to the system continuing to deliver services in a sustainable way. But then the other theme was around the research and innovation process and how we engage people and a variety of publics in that. And I agree with you that that's extremely important. And I think particularly through visualization, DAFNI has something to contribute to that too. So thanks so much. I know you've got to move on this morning with an extremely busy morning. We've got some questions coming in on the chat, but I fear we won't have time to pose them to you. But we will try and pick them up during the discussion later on in the day. But thank you again for joining us, and no doubt you will continue to be informed about how DAFNI moves on its journey into the future.
Thank you very much indeed.